The broadcast is now starting. All attendees are in listen-only mode.
Hey everybody, thank you for joining us today for a town hall mini-series designing frozen delights with SOLIDWORKS ECAD solutions. If you have questions, I strongly encourage questions. The whole team here, we strongly recommend that you ask as many questions as possible. But if you do have those questions, we recommend you enter them into the questions dialog box. These questions are recorded. We will, at the end of this webinar, try to answer as many questions as we can. However, if we don't have enough time, those questions are recorded and we will send an email out privately to you based on what questions you've asked. So quick introductions on the team here. You only see two faces, but in reality, there's actually quite a few other people that are on the call for helping us answer those questions. But let me share my camera with you. So my name is JP Emanuel. I'm an industry process consultant with Dassault Systems SolidWorks. I'm out of the East Coast, or maybe on this direction, depending on how your webcam looks. I've got Thomas Smith. Hey, he's wearing the same shirt as me. Look at that.
Thank you.
Thomas Smith out west. We are the technical team for SolidWorks Electrical. In the middle there, I don't know if you're in the middle, depending on whose screen you got. That's CJ Shirk. He is one of the sales tech guru guys that we have. He's got his nice SolidWorks shirt on as well. We also got Chris Swaim on the call. We have Eric Leafquist, we have Inji Gadala, we have Joe Wilkie, we have Mike Buckley, and we have Vance Martin. We got a lot of people here to help answer questions, and I hope you guys have questions for all of us to answer. So again, at the end of this webinar, we will jump into as many questions as we can. So Thomas.
Yes.
One more slide before we get to you.
Okay.
So if you're unfamiliar with the SolidWorks suite, the Dassault Systems SolidWorks suite, there's a lot of different tools out there. In this case for today, we're really only going to be working with a handful of them, but a lot of people don't realize how many tools we actually have. Simulation, of course, but the collaboration and the visualization, the rendering software, even the CAM tools that we have now. But I just like to bring this up just so everybody's aware that there is more than just SolidWorks 3D that everybody knows and loves, and the electrical design tool as well. So Thomas, we have here our this design that we started with, right? We came up with an idea. I think with the marketing team, or maybe it was our sales team that said, hey, we need to come up with some new ideas. And the first webinar you have to do is going to be on Cinco de Mayo. So I think somebody made a joke about, hey, let's do something with Corona. And I don't think that really went over very well, especially the circumstances we're in right now. So we decided to go with somebody said a blender. And I was like, oh, maybe margarita. But I started looking into it and trying to figure it out. And I said, you know what, a blender really doesn't do a lot for electrical, right? There's maybe a couple small buttons and a power cord you plug into the wall. So we came up with this commercial unit, which has a lot more things to offer and can hopefully relate to a lot of our customers out there that are using these tools.
Yeah, I think, as you stated, the main goal was to, take a project start to finish, kind of given the situation, and JP and I located geographically in separate locations to see how we could collaborate similar to the circumstances our customers are in to create a project from start to finish.
So this webinar series, if I could, I would do a whole bunch in a row, but what we have here, I'm going to close my webcam so you guys have full screen on your end. But two sequential sessions here, and the first session, if you missed that first session, was really driving the project creation and initial workflow, and that was the one we held on Cinco de Mayo. And then during that session, we actually talked about project planning in the 3D experience. We also talked about PDM, and we created our projects for PCB and SolidWorks Electrical inside of PDM ahead of time. And then we went into the SolidWorks PCB schematic tool and the layout tool, and we started to work and show some of the intelligent features within that tool, as well as the main piece of the puzzle when you're talking about SolidWorks PCB, and it's that communication to SolidWorks itself. So that way you can get your overall board design shape on the first try rather than on the 7th try. saving you a lot of time, saving you a lot of money in all the different iterations of that board. Today's session is continuing in the design analysis and finalizing our documentation with our overall Margarita machine. If you're unfamiliar, or maybe you are, the typical design process that I see is people dropping in blocks, dropping in wires, drawing text boxes to create their design, their schematic, right? But then they're taking all that information and they're pushing, creating spreadsheets based on that, their bill of materials, their to from wire lists in something like Excel. And then they still have to go in and audit all that information. Well, what that does, that's the typical design process. But what SOLIDWORKS Electrical allows you to do, I call it the SOLIDWORKS Electrical difference. It allows you to take a lot of that auditing and that reporting and bring it up front while you're doing your design. Because SOLIDWORKS Electrical generates and maintains accurate reports while you design. So if you drop in a symbol and you add metadata to it, you are adding that information to your bill of materials. You don't even realize you're doing it, but you are. You're adding that because it's the way the database is structured, the way this software is designed is to allow you to do that smoothly, quickly, and intelligently. One of the key factors of SOLIDWORKS Electrical is the shared library. No pun intended with our keyed connector here, but this sheet here, this window that we have, is the manufacturer part information about this connector. And there's a lot of different ways I can represent this one particular connector. We have a line diagram, a detailed schematic symbol, a 3D model, and a 2D footprint. Now, there's information associated to those different symbols that are on our schematics and line diagrams, which we'll get into that. But if I need to make a change to the manufacturer part information that we see here in that window, that information will then be pushed out to those symbols without me having to go to every version of that symbol that I have in my schematic. It's automatically going to push that information out, which can be very helpful. Another key factor is the bidirectional communication we have. If you notice in the center of the screen, the component tree is the same on the electrical side as it is on the mechanical side. So me, as the electrical engineer, if I define something, the mechanical engineer simply needs to select that part and can insert it based on the manufacturer part information, as long as there's a solid model associated to it. And the same thing goes for the mechanical side. If I'm a mechanical engineer and I know the spec of the pump that I want to use, and I know the valve that I want to use, or the motor, whatever it may be, I can define that, add that to my component tree, and now on the electrical side, all I need to do is simply insert, and I've got the symbol that has been associated to that manufacturer part. So what are we really expecting to see here today? Yes, we're working with a Margarita machine, but it's so much more than just a Margarita machine. I'm going to go in. I know that I have a task pending in my my schedule here. I'm going to go ahead and move that over so that I get notification. The rest of the team gets notification that I am working on a particular task in our project. We're then going to go into the intelligent functionality within SOLIDWORKS Electrical. We're going to go into the 3D model, and we're going to show some of the connection that I just talked about, that two-way bidirectional communication, as well as our wire routes. And then we're going to finish it off with all the different types of reports that we can create, as well as some other surprises that I have along the way. All right. So the first thing, as I mentioned, is our project planning. I am in Google Chrome right now, but I am also up on the 3D Experience platform in my dashboard that Thomas and I have set up for this particular project. And we can see here, I have a lot of different tasks for this particular project. Now, this just gives me a great view, a great timeline about this particular project. But then there's also a way to organize these and see what I also have pending and projects that I need to work, tasks that I need to work on within this particular project. And one of them that I need to work on is this agitator circuit. I can add additional information about it, but what I really want to do is just let everybody know that I'm ready to start working on it and that it's now in progress. So at the same time here, Thomas, who is the other person involved with this particular task, probably just got a notification on his side saying, hey, this task just went from to do to in progress, letting everybody else know. And of course, I can have multiple users associated to that as well. So additionally, let's jump into SOLIDWORKS, the tool that most of us, probably all of us, have seen or played with and enjoy quite a bit to actually use. And when you're working with the SOLIDWORKS electrical add-in, one of the first things you need to do is work with the project manager. And this, you'll see this again in just a minute when we go over to the electrical side. The project manager is where all of our projects that are that have any type of electrical collaboration are controlled from. This is where we would open these projects up and control these projects. You can see here that I actually have two different projects open. In the case of this, the blue one is the one that you can see behind here right now, which we'll get to in just a second. And that shows that I have that open here on the mechanical side. Anything in red lets me know that other users out there also have a project open. In this case, it's me as well on the electrical side, but we'll get into that in a few minutes. But you can see that there's at least this visual aid to see who is working on what within your environment. That way there's no confusion going forward. But one of the things I do like to talk about is the document tree that we have inside of SOLIDWORKS Electrical, in particular the SOLIDWORKS Electrical add-in here. We can see within this document tree, let me expand my window here so we can see. This is totally,
Hey,
yes.
We're experiencing some audio issues, and the audience is, I think it's pretty much across the board, just breaking up.
Can you still hear me?
Yes, it's sometimes it's breaking up. Just wanted you to know on
All right.
heads up on that.
Okay, let me know again, cut me off again if it starts to. I hope I didn't lose anybody too bad on what I was just talking about with the project manager. All right, so continuing forward here, what we have is our document tree for this particular project. Now, this project, this is how I organized it. Nothing says you have to have it set up this way. You could see here, I have a book, I have folders within that book, but if you already have a company structure on how you like to conform to and you like to set things up, then you can definitely do that. We can help you define that project in a similar fashion. Now, the nice thing about these document trees here, especially from the mechanical side, I can go ahead and I can open up one of these files and see the progress being made to the electrical side. Now, I can't edit this file from the mechanical side, but I can at least view the information that is there. So if I need to know something about this particular circuit board or this contactor or terminal block, it's here, it's available for me to find that information out without having to go and track down the electrical engineer or whoever decided to build this schematic. Maybe they took off that day. So it's a nice way to figure out that type of information. The other really nice thing that I thought was really cool when I first started using this is the ability to actually embed spec sheets right into my project or point to a folder that all my spec sheets are controlled from or housed. Maybe it's in my vault, all my spec sheets. But by having this hyperlink right in the project, there's no confusion about what parts are being used or any of the information about those parts. And if I have access to it, that means Thomas has access to it. That means Joe and Ingy and Eric also have access to it as well. So going back to our model here, our first look, I don't know if we really even took a look at it last time when we were working with the PCB side, but you can see here, we have our assembly. I have it open right now because I wanted everybody to kind of get that visual aid of where we're going within our schematic. So let's go ahead and jump right into the SOLIDWORKS schematic tool. So I have SOLIDWORKS Electrical open, and the reason I have it open already, first I'll show the project manager. You can see here that both of them are in blue now because I have two projects open within my document tree. But the reason I have it open is because I've already checked it out inside of PDM. So this is connected to PDM right now. I have everything set up. We have a PDF in here. We'll get into this again in a little bit. I have everything organized just as you have it organized here. And when I go to check this back in later, we can see the PDF, the Smart PDF as well, that we'll get into it. I won't go too deep down that rabbit hole right now. Inside of our document tree, same document tree that we just saw over on our mechanical side, let's take a little bit deeper look at the different types of sheets that we have within our document tree. And the first one we have, I call it more of the high level overview or the top level design, but it's a line diagram, right? A block diagram. This is just what I like to use it for because I'm always doing detailed schematics. But there's a lot of people out there who can just use this as their basic schematic. And by even creating just this basic drawing here, I can connect models and really start to create valuable outputs such as our bill of materials, such as our to from wire report or cable report, and connect it to the 3D assembly as well. And if we notice here, I can start with this. So maybe I don't know the detailed pinout yet for all my connections that are going to be on my circuit board, or what pins I'm going to, what connection points I'm going to be using within my contacts or my terminal block. But I do know I'm going to be using those parts. So I can start to really develop my bill of materials right from the get-go with just a basic symbol with just some basic metadata. The other nice feature here, before I jump into the schematic, is our 2D cabinet layout. We do have the ability to create a 2D cabinet layout on the 2D side before we even really want to jump into and invest a lot of time in the 3D assembly. We can also just do it here on the 2D side. And finally, let's go into our actual schematic. So here is just a basic schematic for this particular unit. It's not very big, but we can expand on this a lot. And if you remember that task that I created over in my project planning up on the 3D experience, I need to add agitator circuit for this. And I can go ahead and show basic insertion of different symbols, but that's not what we're here for. I want to show you some of the intelligent functionality that's already available. If you want to learn more about adding symbols or drawing wires, we have plenty of other videos up on mysolidworks.com about how to do that kind of information, how to create that information. But what we're going to do here is I'm going to go ahead and use a macro. It's not an Excel spreadsheet macro. This is more of what I personally like to call a common schematic, something that I'm going to use over and over again. And so another project that I worked on in the past, I've already created this agitator circuit. So I'm simply going to go ahead and drag this in, and I'm going to place this, let's say roughly right here. I have the ability to change information about that before it actually becomes a part of this project, but I'm going to go ahead. I know what I'm doing with it, so let me try that again. I guess I don't know what I'm doing with it. It didn't do what I wanted it to do. Here we go. So I'm going to keep existing mark. There we go. All right. I do need to go into the wiring, the wire tool here for a second, but the really nice thing about setting it up this way, if we notice that in my macro, I have a couple different wire styles. I have a black wire and a gray wire. I don't have to go into my wire style manager, find the wire type that I want to use. Based on the wire that I select, it'll automatically grab the properties of that. I'm going to go ahead and hook this up and do the same thing over here. And just like that, I've now created this new circuit. It took me a total of 30 seconds to really create this circuit. I did build it ahead of time, but let me go ahead and show you how I built that ahead of time. So very quickly, in order to create a macro, maybe let's say these circuits down here, maybe this part of the circuit is something I'm going to reuse down the road. Well, all I need to do is simply highlight those parts. I'll grab it right here. And I can drag it over into my macros palette. I can give it a new name. I can put it in a specific library. I can define it a little bit more with a better description. And just like that, I've now created a new circuit that I can reuse over and over and over again. It's better. It's extremely more intelligent in the fact that now I don't have to go find that old project that I've been working on and copy and paste the old Control-C, Control-V feature that we all know and love, and grab that from the old project and pull it in and try to line everything up just right. The nice thing with this also is that all the metadata about these symbols, about these parts, are also included within that macro. The other nice thing about that is that because we have a shared library and we're all sharing, my group here is sharing the same library, I created this macro, immediately everybody else has access to that same macro. So I can be in charge of creating all this content, and then everybody else can just go ahead and utilize that and absorb that information in their projects, depending on what they're doing. So taking this a step further, the macro feature can be, again, was probably one of the most powerful features in the software. But taking this a step further, if you notice here, I have several different versions of these same circuits on the right-hand side in what we call our macros panel or a macros pane. Well, there's a feature in SOLIDWORKS Electrical called Excel Automation. And what Excel Automation does is it allows me to take these macros, utilize the naming convention that I have for these macros, and I can create an entirely new circuit based off of that. Now, what do I really mean by that? Well, first, let me go in and set this as current. And I'm going to go into my 3D Experience platform again. And I have what we call our project configurator. Doesn't want to play, so I luckily opened up the actual Google Sheet that I have for this. You can use a regular Excel spreadsheet or Google Sheet if you want to, if you're going to collaborate with multiple users. So that macro naming convention that we have for each one of those macros, I've defined and I made a list inside of Excel. And if we all know, Excel is extremely powerful. And why am I going to do this? What is the purpose of creating this? Well, Thomas and I came up with an idea for this is why not have different iterations, different versions of this machine? Maybe we want to have 2 mixers on the machine. Maybe we want to have an oversized unit or maybe a miniature unit, depending on what your need is as a customer, right? So what I've done is I've created this spreadsheet, and this information here is capturing certain information that we want to show up on our schematic sheets over on the electrical side. But more importantly, what I've done is I have a master list here. I've also created a configuration for that master list, so I don't have to go and know exactly what field and everything I'm looking for. I can come into my project, look to the configuration. I want it to be on an ANSI sheet. I want it to be a standard size. We're in the US, so I'm going to go ahead and pick US 110, and I'll add the agitator into this. So based on this criteria, now it's going to go ahead and turn on and change the fields that I want to show up. NAs, anything that's not applicable, is going to be ignored. Anything that has a macro name in it is going to go ahead and be added. So now, based on that, all I need to do is download this as a spreadsheet. And now when I come back into electrical, I can import that particular sheet. Here's my downloads folder. It's going to go ahead and validate those macros that I've added. And I now have this brand new schematic. So yes, it took me a little time up front to create this particular macro, these different macros that make up this entire circuit. But I build it once, I save it off as a macro, and now I can utilize this configuration tool. And again, if you want to see it change live, if you don't believe me here, everything's set up as ANSI. I'm going to go over and I'm going to change this to IEC, and let's go ahead and take a look. Notice that those automatically change to IEC. So now for this customer, I would come back in and go to download. I can find that. It's going to create another file for me. So very quickly, we can start working with the same schematic information, but be processing this in, and our design cycle becomes that much faster based on this type of functionality that we have here. All right. So once we're done with our Excel automation, I'm going to go ahead and close that out. I just think that's a really cool feature. I wanted to bring that up. I think it's extremely powerful. But what we're really going to be working with here, again, is our main schematic. And let's go ahead and connect this information back up over to our connect this information back over to our 3D assembly. So we have our 3D assembly after we did all those tweaks to our schematic, and we have our component tree, that same component tree. Remember that slide I talked about, the bidirectional information? This is that component tree I'm talking about. Well, there's a couple parts that we just added, right? We had that transformer and we have our cap that we have to add in here. So what we're going to do is we're going to find those parts. And T1, which I think I was messing around earlier and I added them. So we're going to just remove them and I'm going to put them back in again. So as the electrical engineer, a lot of people get scared when they try to jump into the mechanical space. There's a lot to do in the mechanical space, but what I want to show you is something that is extremely easy to do, and you don't need to know how to do a lot inside of the mechanical side of the tool. You can let the mechanical engineer or your team of mechanical engineers put this whole thing together. They can mate everything up and put everything where they believe it should go. But in reality, do they know which one is contactor 1, which one is contactor 2, terminal block 1, so on and so forth? Maybe, but you probably know way better than they do on where those parts are. So what you need to do is simply find that part. So in this case, C3, I'm going to simply select associate. I'm going to find that part, highlight it, I hit enter, and that's it. I've made that association. So there's no manipulation of the model other than you're telling the software, hey, I want this to be called Transformer 1. And just like that, may take a few minutes to get all those parts in there. I've already gone ahead and I've added all the information and associated all these parts up to my mechanical assembly. Once I have that, the next step I'd want to do is I'd go in and I would define what we call our EW path. Why do I want to create this? Well, what this is our guideline for our wires. Because if I just go ahead and draw wires and try to route wires, because that's the next logical step, right? We want to go in and actually get lengths for all the wires and cables in our project. We need to tell the wires kind of where to go through certain bulkheads or around a duct or up in the overhead, where that stuff needs to go. Because otherwise, if you don't put this in, it's still going to route, but it's going to route where it wants to route, not where you told it to route. So by setting this up, which doesn't take very long, it's a simple 3D sketch, we can go in, and after we set that up, we can come in, we can route our wires, and we can either do a sketch line or a full solid route. Now, to save some time, I've already routed them, because we don't want to sit here and wait 3 minutes for a sketch and maybe 10 minutes for a solid route, which is still a heck of a lot faster than trying to route every single part by hand using standard just C points in the software. So taking a look at those different types of routes, let's see what we get here for our sketches. You can see here that we have, turn off our EW path so you get a better view. So this is what our sketch lines look like. And the nice thing with sketch lines, it's a quick down and dirty view of what your wires are going to look like, and you also capture the length. So you don't even necessarily need to do the full solid route. But I know a lot of people like to see what the solid route looks like. So here it is for your viewing pleasure, is the full solid of all the wires being routed, which is great. You can start to figure out fill duct ratio as necessary. But the other cool thing about it too is now I've created this. You may have seen an image on one of our varying platforms of where we push this information about this is marketing material, right? We have all the wires routed in here, and we have a nice visual aid to show to our customers on how nice, how neat everything can be inside of our cabinets moving forward. And again, both of these options, routing sketches or full solids, will provide the wire length at the end. So now that we've got our wires in there, the next step we want to do is go back into our electrical tool, and we want to generate our reports. So we have the ability to either do design rule checks, so things like fill duct ratio or missing pins on a connector, or too many wires in a connector, or maybe one of my other favorites is not the right, maybe it's too large of a gauge of wire for that connector, which you can define. It's metadata that you can define for that part. But for this, I'm going to go ahead and do my bill of materials and my wire list. When I want to do this, generate my drawings, I'll create those. One thing I do like to point out is I have the ability to export to Excel, export to a TXT, or an XML file as well. For this, again, I'm just going to generate those files. Let the software grab all that information out of the tables, out of this for this project. And just like that, we have our bill of materials. Taking a look at that bill of materials, I've organized this based off of location. And our locations for this is I have the top level of our electrical enclosure. I also have the top level, the bar and grill, the image you saw at the very beginning of the presentation. And then we also have the full drink dispenser itself. So there's just the small cabinet. So we can start to really organize our parts based on different locations within our project. So you can have 3 or 4 or 10 different types of bill of materials. Maybe you want to create one bill of materials that's strictly for your logistics team. Or maybe you want to create a bill of materials that is just for the guys on the shop floor, the team on the shop floor, because they don't really need to know where you got it from. But in my case, where I got it from, I get a lot of my parts, as you can see here, vendor and vendor part numbers. I get a lot of my parts from Allied Electronics. We have a good partnership with Allied Electronics and RS Components. So I utilize a lot of that information with my manufacturer parts. Taking a look at our wire list, we can see that not only do I have each individual wire and its specific length, which I can conform to either inches or metric, whatever I want, but it also gives me a total. So depending on the wire type and how much I'm using of one specific wire, now I know ahead of time how much I really need to order or how much I need to charge the customer for based on how much wire I've used. So going back real quick, what we just did is we went through the project planning, and I went ahead and created that. I moved that project over, which afterwards I'm going to go in and mark that as done. But we went in and we took that task to do and made it in progress. We went to the intelligent functionality. I really didn't show a lot. There's as far as the macro goes, is the main meat and potatoes behind creating our schematic. There are so many more intelligent features that I didn't really even cover, because creating a terminal block drawing for this particular assembly really wasn't, really didn't fit into the grand picture of it. But creating terminal blocks and creating terminal block drawings is another really intelligent feature. And I do have other webinars that I can share with you if you want to see more about that. Origin destination arrows and all the information about those as well. We took a look at our 2D cabinet layout. Nothing says you have to jump into the 3D space. If you want to utilize just the 2D side, go for it. We have the tools here to be able to do that as well. And then our Excel automation, which is one of the most extremely powerful features of this tool altogether. Why reinvent the wheel? We can go in and really have a what's the word I'm looking for? I'm at a loss for words right now. It just helps to organize our structure, our process going forward within our organization. And then finally, we went through the 3D model. We looked at all of our wire routes, and we created our reports. But closing the loop, that was just on the electrical side, right? That was just electrical, what I did there. But over on the mechanical, on the PCB side, we didn't really finish this off last time. I want to close the loop with what we did in PCB. We also have all the exported files and the file types that we have for SOLIDWORKS PCB. Now, Thomas, I don't know if you want to talk to this for 30 seconds about what we have for PCB. You there? You're still muted.
All right, JP. Yes, I was messing around with the mute. But yeah, so yeah, closing the loop, we're able to, on the PCB application side is also obviously be able to export all our manufacturing files. So whether that's the Gerbers, the ODBs, the drill files, etc., all of that is able to be generated automatically with various options inside of the PCB tool, and then also within our PDM workflow as represented here. We demonstrated in the previous presentation managing all the project data, the schematic sheets, etc. And then here you can see, again, just kind of full circle, also managing all of the outputs inside of PCB as well.
So one other thing, you have here, this is the different type of, these are all the different files, right, that you created for this?
Yes, so yeah, if you look in the explode out there, again, an automated, process of creating these outputs, they're all generated in here, and in this particular one's just showing some of the Gerber, the files contained within inside the Gerber folder.
Awesome.
But yeah, all of that, again, automatically generated either from application and then with the PDM workflow managed, so that the whole, enterprise can have access to that.
So taking this a step further, thanks, Thomas. So taking this a step further, I also had some of the members of my team here help me out with other parts of our product suite, this particular simulation. And we created these really awesome visuals to help us define and design this assembly here. And when I first, quick story on this, when I first created this assembly, I had no idea how to really design a fan blade at all. And I created a piece of sheet metal to make it look like a fan, because really I was trying to do the electrical side of the house, right? But when I passed this off to our simulation team, they looked at me and said, this isn't going to work. You need to actually build something here. So I went in and I learned how to build a fan. And these are some of the images that they provided to show the cooling and the flow of air within this assembly. Additionally, they sent this cool little video here to show how that behaves with the circuit board, as well as some of the other components within our assembly. So there's a lot of stuff you can do, and not just simulation. And one other thing I need to mention, because they did help me out and created this stuff for me, is they are having a webinar tomorrow. If you're interested in any type of simulation, they are doing a CFD webinar tomorrow. I believe it's at 1 p.m. But if you want to learn more about that, let me know and I will get the information for you. The other nice thing is, again, who else is on your team that you're working with? It's not just electrical and mechanical, right? There's obviously the management team, there's the CAD admin team, there's marketing. So you can create some really awesome visual aids, such as like I did here. This only took a few minutes for me to create inside of SOLIDWORKS Visualize. And you can see I thought they came out pretty good. So hopefully everybody else does. But you can also do things like this and create some cool visual videos to really kind of go along and tell the story about your design or what the machine does, and give specs on it and stuff like that. So again, you have to think about these kind of things. Who else can I share my data with? Who can I communicate effectively with? And again, the design teams, the assembly teams, the CAD admin, so on and so forth. The overall benefits of this is, without a doubt, the communication and collaboration between specifically the electrical and mechanical design teams. Everything I showed today was really trying to connect the dots between the mechanical and electrical engineers to help make their lives easier, so you're not constantly acting like a gopher, putting your head up over the cubicle wall to talk to the mechanical guy and back and forth and back and forth. A lot of this stuff is to help you streamline that process altogether. So with that said, I knew I threw a lot of information at you, and again, I barely scratched the surface on what this tool can really do. But we're going to open this up now for some of the panelists that we have here to help out with some questions.
Yes. So so I'll help facilitate those questions, JP. And I just want to start by saying thank you, for the presentation. I really, enjoyed how we can see all those different pieces, coming together. So that was really good to see. So, but with that, let's jump into the questions. And in fact, we'll start with you, JP. So let me grab one here. So in your presentation, you showed a 2D layout that you generated. What
Okay.
kind of connectivity, though, can we have between a 3D model and that unelectrical 2D drawing? Meaning, is the electrical enclosure layout able to be linked and updated with a 3D? Now, I know there's a difference between the two, but I'll let you kind of explain what's possible.
It's really the metadata that's really the connection. Remember that slide I showed at the beginning? It's all the metadata that we have about that part that is the connector between everything. That key factor slide that I showed, right? So if there's specific information about that particular part, that is really the drive of being able to connect those two. Now, if I need to remove that part, there is a feature, there is a piece of functionality called a permanent component, right? So if I delete that 2D cabinet symbol, it won't delete the, let's say it's contactor 1, right? And I'm showing contactor 1 in my 2D cabinet, but I also have it in my 3D assembly. If I delete the symbol from the 2D cabinet, if it's a permanent component, it will not delete on the mechanical side. If I don't have it as a permanent component, any instance of it on the electrical side could potentially remove it from the mechanical side, which in some cases, some people want that to happen. So there is some ways to manipulate that information back and forth. I hope that answered the question.
And it did. And one thing I think I also want to reiterate is when you have the integration between the schematic tool and our mechanical tool, we can also obviously produce a 3D cabinet layout. Off of that, we can create the 2D drawing that's pushed into the electrical project. And now say if mechanical adjusted that layout, they can republish that drawing and it does push those updates out to the 2D drawing associated with the project.
Yep.
So yeah, kind of, yeah, those two separate options. But if you have the integration with mechanical, then you can automate the updates to the 2D drawing.
All right.
All right, let's see. Got a lot, so pardon me. So I think it's around the same lines, JP, when we're talking about connectors. But somebody asked here, how do you import SOLIDWORKS electrical data into mechanical without PDM? And I assume when they say electrical information, it's more of the metadata, you know, that we're associating to. So I assume it's the connectors what you want to talk about.
Yeah,
the add-in.
The add-in, the SOLIDWORKS electrical connector, that component tree. That if you remember that slide that I showed, there were two arrows that were going back and forth between mechanical and electrical. That component tree is part of the add-in, and that is what is really the glue that holds the two sides together. So if I have the information in that tree, it will be available on the mechanical side and vice versa on the electrical side.
Perfect. Well, the questions keep coming for you, man.
Oh, boy.
I'm going to keep you on here for one more, just because you were the one who did it. Can you edit the macros after they are created?
Absolutely. So go ahead.
Go ahead.
The second part of your question.
There was a part 2 to that. And then does it update the original macro that was placed?
No.
So two-part question.
Yes, and the reason why it doesn't is because let's say you have legacy data that's using that original macro. You don't want that to change. So what I've done is I'll create that macro and I will essentially create a copy of it, right? And then I will edit any of the information. Maybe in Rev 2 or version A, whatever you want to call it, there's a larger motor, right? You know, in the case of my Excel automation that we just showed, I had a standard size, an oversized, a dual. So maybe those different versions require larger components, right? So that's where that kind of manipulation would come into play. Not only that, but you can take that macro and now graphically add even more stuff to it next to it. And you can do that again. So take the second one and turn it into a third one, turn it into a fourth one, so on and so forth. So
perfect. Awesome. All right. Well, I'm going to let you off the hook, but before I do, you put us all on the spot last time we were here asking us quarantine questions.
Oh, boy.
I know you like to cook, and given the fact that we haven't been able to, go out and dine, what is the coolest thing that you've done at home to, keep things interesting in the culinary department?
So I actually set up a hibachi kitchen with my little griddle that I have in the house, and I actually have it here. Hold on, I have it right here.
I was hoping you'd pull out the video because
no, I actually made this. I made this, so I was the chef in the kitchen with the little thing, and I had the little fake sake thing for everybody, and it was pretty fun. I had had the whole thing going with
Yeah.
the flipping of the shrimp and everything, so that was
Yeah, I
probably
saw
the
it on
most fun.
Facebook. Yeah, and that's why I wondered. I was hoping you'd mention that story because yeah, it looked like the true hibachi grill. So good work there, keeping it fun and interesting during quarantine. All right. So you're off the hook for a minute, but I'll be back to you, JP.
All right.
Eric, I have a question for you.
Yeah, Thomas. Hey, I'm
Hey,
here.
there you are, Eric. So for you, Eric, is it possible to have information from another tool included in my component?
Yeah, there's a few different ways we could answer that question. My favorite answer to that, Thomas, would be something that JP actually showed in one of his segments here a few minutes ago, and that was the use of data sheets. So, he spoke a lot about connectors and motors and contactors and things like that. And so when users go out and start to size the equipment that go into their designs, one of the big things is knowing, which version that they looked at, knowing the characteristics of some of those devices that don't necessarily go into the metadata.
Yep.
And all that information can be carried in the data sheet and stored right in your project. So to me, that's a cool way to deal with this kind of data that you might need or you will need. You're not sure, save it as a data sheet.
Definitely. And another thing I think that kind of would roll into this is being able to include in like other additional user attributes where we can put in other, manufacturer's information or any type of information into any user fields to include custom data that might not initially be represented in there. We have the ability to add additional information into our metadata through the use of user attributes and such. So
Great point.
It is possible, yeah, I think, to answer that question. So thank you, Eric. And let's see, I'm going off the fly here, Eric. I can't remember what JP asked last time, but quarantine, what's the most fun thing that you and your family have done to stay sane through this?
Well, we live in a warmer climate, so we grill a lot. So we've tried new things, particularly grilled vegetables outside. So
Okay, nice.
that's been,
I've been on the
fun.
man in the grill myself. So, well, good. Well, thank you, Eric. Let me see if let me pull out another question. We got plenty of them coming here. So I had to get through. Everybody was letting us know we had some slight audio issues. All right, so I'm going to call it back on JP for this one because it's a Excel automation question. So thanks again, Eric.
All right, I'm coming.
All right, I haven't fully read through it. I'm getting it now. Would the Excel automation tool allow me to do different project configurations, or does it only apply to documents?
That's a great question. So there's another level of macros that is called project macros, which combines multiple sheets. And by creating one of those, that's still the same naming structure, and you can call out one of those multi-sheet macros. We call them project, like I said, project macros, and you can call that out inside of the spreadsheet. So yes, I would need to take a closer look at what your design looks like to give you a definitive yes, but for the most part, absolutely, it could definitely handle that type of a larger, more than just one sheet or a small piece of a schematic.
Yep, and that's exactly where I was going to take this answer to is yes, project macros hit that, I think, is exactly what they would be looking for. So yeah, if we can do it project level and then we can isolate down into schematic sheets. Let's see. Let me see, I might bring Eric or Vance on for this one. And whoever feels like answering, it's
whoever's feeling froggy.
Yep. So we'll pull either one of you guys. I'll just ask the question and then you guys can come on. But what about any interactions or any integrations with Innovia and this data that we produce and work with electrical? We had that question come up. I think you're still muted. Let me see if I can unmute.
Vince, do you want to start? Do you want me to start?
Oh, there he is. Hi, Vance. You're unmuted.
I think he's on
Is that better?
Yeah,
There you
we
go.
gotcha.
So it's something that we have planned for the future and is actually nearly completed. We've been working on that over the past year. I don't know, Eric, if you want to elaborate on any details.
Yeah, so that's a good start, Vance. Good point that this is something that we don't really have fully available today, but the full power of Enovia to manage your business. We saw a tiny bit of it in JP's session today with his project management section. He showed some of the tasks in the project planner from Enovia. So that's just a start, but there's many, many more aspects, like Vance says, that are coming, and we'll be able to manage all of our data there in all aspects of the mechanical, electrical, all in one place, PCB, all of those things, all in one place. But today we have certain pieces, including the Enovia project planner that we saw.
All right. Well, great. Yeah, thank you guys. And maybe this would be a good time, to just go ahead and ask about, the cloud and the electrical application in general, what the path might look for in the future with as we continue to move that direction. And
Vince, you want to start on some of that, or?
Sure. So what's underway right now is we're trying to, like I said, we're nearly complete with tying the data management aspects into the cloud-based tool, into Enovia. Then you will start to see connections into the various online tools of the Works platform and CATIA. And then have not begun work on this yet. Whether the schematic tool will stay desktop, be a more local install, or be on the cloud, that is something that is being researched about what will give us the desired result and what will also give us the best use of R&D's time. What's the most efficient way and the best result to achieve the goals that customers want.
perfect. Awesome. Well, thank you guys for providing that insight and that update there. So moving along, I'm going to pull Joe Wilkie up. So Joe, if you're ready, I will present a question to you, sir. Oh, I think we're still muted. Or JP can.
There we go.
All right,
So now
welcome.
I'm not muted. It was good.
Okay.
What can
All
we do
right.
for
So
you?
yeah, tell me, does SolidWorks Electrical work with older versions of SolidWorks, say 2016?
Well, if you're just developing schematics, it really doesn't matter what version of SolidWorks mechanical CAD you're using,
Okay.
because the electrical data is totally separate from that. If you're using electrical 3D, so you want to take advantage of some of the automatic wiring and the interference detection and the flow simulation and great renderings and all that other cool stuff JP was showing, it would make sense to use electrical 3D, and for that you would need to have everything on the same version. So if you're running SolidWorks 2016, you'd want to run electrical 2016 and electrical 3D version 2016 as well.
Okay. Perfect. Well, I think that, yep, that answered the question. Let me see if I got another one for you here. The question list is getting pretty big. Okay, I do got one for you. So is there a way to show the same part that might be included in different assemblies? For example, when we look at like a back shell can be used in multiple versions of the same connector, but can have a different part number. So how do we handle a situation like that?
Well, from what I've seen, I think probably the best way to handle that would be what we call an electrical assembly, where every individual component of that connector has its own unique part number. So we know the back shell, maybe there's a back shell that sends the cable out at 90 degrees and one at 45, one straight. Those are all different part numbers. Maybe I've got different pins, different seals, clamps, all kinds of things that might need to go with that part. So with electrical, we can build up our library to have each one of those individual components, but then we can also combine those into useful configurations. So maybe I have a certain connector with a 90-degree back shell and a strain relief with a, whatever characteristics I need. I can just put all those parts together so that with a single database lookup, I can call up that item and add all those individual part numbers in that assembly into my bill of materials.
Exactly. Yep, that's the same thing I was thinking. Electrical assemblies will allow you to accomplish just what you were asking there in that question. So thank you, Joe. I guess real quick, and I forgot to get you, Vance, while you were on the line, but Joe, what's the most interesting thing you've done to keep yourself entertained during quarantine?
Well, I mean, besides this webinar,
Yeah, of course. Yeah.
well, we've had a lot of webinars, a lot of meetings like this. I think what's really helped me keep my sanity is the fact that I've probably taken about 20 or 30 flights fewer than I would have taken in the same amount of time.
Yeah.
So it's been that's been kind of relaxing.
Yeah, I can relate to that. Yeah.
Fly record a break, right?
Yeah, it is nice not to see the inside of an airport for a while.
It is.
So, well, thank you, Joe. I appreciate you being on and with us today.
Sure thing.
JP, I'm going to pull you back on.
Oh boy, here I come.
Let's see. Yeah, we got a few more minutes for a few more questions. So, can you create global wire styles that can be used in all projects?
Yes. So the way I would do it is I would create a project, and once I am done working with that one particular project, what you would want to do is create a template from that project. And all the information that you created is now going to be a part of that template. So when you create a new project, a second project now, right? When you go to hit new, there is a drop down that allows you to pick what type of project you want to choose from.
Right.
There's quite a few people that have different templates based on different customer requirements, or different templates based on areas of the world. Maybe it's a IEC version versus an ANSI, like the Excel automation tool that I had set up. So what I would do is set all those wire styles in the first one and then create a template off of that. And then now going forward, every wire style you have is in every project that you start. So.
Yep. And so that, yeah, JP answered that one great. And then just to kind of build on with Excel automation too. So you could have a general template that you're used. So one template, and then with Excel automation, we could feed in project specific wire styles into each project. So if what the user is looking for is, I don't know, just different ways of pushing data in, I guess. But yes, as JP stated, we can create templates and there's a variety of things we can do to get the appropriate wires in each project. Let's see. So what is the best way, now this one I got for you, what is the best way to work with an ERP connection inside SOLIDWORKS Electrical? And which software is recommended to use ERP? Or I guess they're asking what software in ERP would we recommend? I don't know if we can get that granular, but is there a means of ERP connection with SOLIDWORKS Electrical?
Yes, there is. There is an actual connection that you can, there is functionality that allows you to connect directly to an ERP system. So if you have an existing manufacturer parts library that you have to use, we can connect to that. There's so many different companies out there for like just ERP databases. A lot of them work. I do know that there's companies like, not to really plug them, I don't even know if I'm supposed to, but CADlink is one that will help set that up, because I've worked with them in the past with a couple companies. That's just a third party who will help initiate that link between the two. But if it's just something that you want to connect to another SQL database, we have that technology built right into our software. It's a matter of mapping those attributes from one side to the other together.
Exactly. Yep. So yeah, we do have that right available in application out of the box. So good call there. JP, I had one I wanted to ask you, and now in my huge list, it disappeared. But let's see. This one's about revisions. The revisions that we add in the electrical project or PCB project, can we put them in as a PDM revision, or are they processes that have to be done separately? First add the revision in electrical and then add it in PDM.
I am still learning the PDM side, so Thomas,
I'll take that one. Yeah. So yes, we can manage revisions on various levels with PDM. So there are ways, that we can version as we're checking in our projects, our drawings, our output files, etc. Can all be versioned and PDM can track and maintain those revisions. But separately, if PDM is not in the equation, electrical does have its own revision built-in system. But when we look into PDM, we normally drive off of the PDM revisions. So hope that answers that. And I wish I could find this other question, man. This list is pretty.
I am.
All right, here it is.
Keep coming in.
It was one that somebody had answered, but
this might have to be our last one though, because we've got we're coming up to the top of the hour here. So
yes, and it was a good one too. It was essentially they were asking about design rule checks and all right, is it possible to take consideration the wire size in 3D? 14 gauge do not take much place of, but 0, 0, 0 AWG may give some issues in placement. So what's our solution for that? So inappropriate wire sizing.
What's the best way to answer that one? So inside of, I kind of touched on it a little bit. It depends on if you're trying to route wires. Inside of every wire style, you can define the gauge or the diameter, and also the bend radius. And the bend radii comes into play with, especially for things like fiber, right? Or maybe, like a 24 gauge, really not a big deal. But for something that's larger, 14 gauge or, 00, you're getting larger, right? And it's harder. You can't bend it like this, right? Those require a larger bend radii. So you can define that inside of the wire style. So when you do go to route, now it will force that bend to be a lot bigger. What I've seen is when you get into those larger things, you might have to manipulate your EW path, that routing path I talked about, to conform to that a little bit more. So there might be a little trial and error when you start to get into those really big honking cables. So for small stuff, no big deal. That stuff follows a path really easy. I hope that answered the question right now.
Yeah.
A second part to that, right, is your design rule checks that you were talking about. You can create design rule checks for that, like depending on connecting to, maybe it's fill duct ratio is one. I'm trying to think of them off the top of my head. I mentioned fill duct ratio before, or connectors, right? Like you have a connector and it can only accept 20 gauge, but you have a 16 gauge or a 14 gauge trying to connect to that. You'll get not an alert, but you can run a report essentially and show, hey, these are wrong. In here, and give you the opportunity to go fix that.
Yep. Okay. Well, great. Yeah, I think hopefully that answered your question. And we are coming to the end, everybody. I wanted to thank you guys for being on. Any questions that we didn't get to, you will receive a follow-up to this, a recording of this particular webinar, which should go out tomorrow, and you should be, as this slide says, should be receiving that. So I'll let you take it from here.
Thanks, Thomas. So again, thank you everybody for joining us. This was session 2, as Thomas just said, and I was going to cover it again. This is being recorded. Session 1 was also recorded, and we will be attaching this to the original registration that you got. So you will receive another email tomorrow, roughly around 1 p.m. Eastern time. Usually goes out about 24 hours from now, with a link to that. If you don't get a link, send me an email. I'll send you a link to my go-to stage where these also get put up on as well. With that said, thank you everybody for joining us today, and I hope you learned something. Again, if you have more questions, feel free to reach out to us. Those questions that we did not answer, we will get to those questions later on. So thanks again, everybody.
Yep.
Have a great day.